Welcome to Maths with Bob. Today we're looking at matrix multiplication. We're going to start off by a little bit of an intro and multiplying a matrix by a number or a scalar. In this case we're going to multiply by 5. Okay, now let's actually have a quick look. Okay, here we have matrix A. Let's try to make it a bit smaller. Okay, matrix A has been given this grid, if you like. We're going to actually call this grid called matrix A. Okay, so we normally let matrices or matrices be letters, usually A, B, and C, etc. So this, you can see here, is a 2 rows by 3 columns. We'll go over that in a minute. And you can see matrix C down here is, if you have a quick look, it's actually 3 rows by 2 columns. Okay, so how do we actually do that? Well, let's have a quick look. A, 2 columns by 3 rows. Right, okay, so A is a 2 by 3. And let's have a look at C. C is 2, 3 by 2 columns. We always put the rows first and the columns second. Okay, so it's A is a, you can see here, 2 by 3, and C is a 3 by 2. Okay, now how do we actually multiply a matrix by a number or a scalar? Well, it's pretty easy. We just take each element. Okay, so here's the element 1, and we have a quick look at the scalar. The scalar is 5, so we need to multiply it by 5. 5 ones are 5. It stays in the same position, right? 2, multiply 2 by 5, and obviously 2 5s are 10, and obviously 3 5s are 15. Okay, 4 5s are 20, 5 5s are 25, and 5 6s are 30. Okay, now it doesn't matter if they're positive or negative. Let's have a quick look over here. Minus 7. Minus 7 times 5 obviously is minus 35. And let's have a look. Minus 23. Okay, by 5. Okay, is minus 115. Now, okay, so just remember, put them back in the same spots you got them from. Okay. All right, that's pretty easy. Okay. All right, so let's actually now look at what's called matrix multiplication. So I'm multiplying a matrix by a matrix. But the first thing is we do need to be aware of is that you just can't multiply any old matrix by any other old matrix. It's not like addition. Well, addition, you have to be the same size before you can add them and subtract them. But here you've got to be really, really careful that in fact the columns of the first match with the rows of the second. Now, what do I mean by that? Well, if you look at the columns, here's 1, 2, 3 columns of the first have got to match with the rows 1, 2, 3 of the second. Okay, and the resultant is okay, a 2 by 2, which is in fact the number of rows of the first and the number of columns of the second. But we'll just go over this quickly just to see how this works. Now, okay, so this is quite important. Okay, so it has to be, okay, this is quite important. So first up, its columns of the first matrix have got to match the rows, okay, the rows of the second matrix. Now that's the actual enlargement's gone off the screen there, but the second matrix, okay. E.g., if A is a 2 by 3 and B is a, you can see here, a 3 by 2, okay, then the result I've highlighted in red, well, the actual resultant is a 2 by 2, but the part which is highlighted in red is the part you have to look at, which is, if you have a quick look, it's this one here. Okay, the 3 here and the 3 here, both in red. You have to make sure that they actually match up. Okay, and the resultant, okay, the resultant will in fact be this one here, a 2 by 2. Okay, so you can see here that if we multiply a 2 by 3 by a 3 by 2, okay, it is compatible. Okay, we can do the multiplication. Okay, because we checked it. The okay, the columns of the first match with the rows of the second. Yeah, the 3s and the 3. Yep, that's okay. Now the resultant matrix formed is a 2 by 2, and what I always usually do is actually I just write down what the resultant matrix looks. Well, the actual matrix itself, and just leave blanks and put the numbers in later. Now you'll see we haven't actually worked out how to get these numbers here, but you'll see. Okay, we are assuming compatibility of the two matrices. We can multiply them, okay, and the multiplication will exist. Okay, that's because the 3 and the 3 match up. Yes, that's okay. And the result, you know, is a 2 by 2. So as I was saying, what I usually do is I just write down what the resultant matrix would look like. Okay, a 2 by 2. I just write a blank one and just leave the 50 or these positions blank, and then we'll try and fill them in. And how you fill them in is a bit of an old saying. You pour the rows, this row, down the columns, this column. So that's row 1, column 1. That's the 50. Okay, row 1, column 2 will be the 68. Row 2, column 1 will be 122, and row 2, column 2 will be 167. Now, just to give you a quick heads up how this happens is you go on the pour, you multiply the numbers, and then you add on the next section of the pour. So you go 1 times 7 is 7, and then the rest of the pour is 2 times 8 is 16, 16 and 7 is 23, and then the last section of the pour is 3 times 9 is 27, and 23 add up to 50. Okay, so that's how we do that. I'm going to go over this in much more detail shortly. Okay, so just a quick overview again quickly of the resultant matrix. Okay, the resultant matrix, as you know, is a 2 by 2. Okay, which is actually, you can see here, it's the rows of the first matrix by the columns of the second matrix. Okay, so that is the resultant matrix, which I was saying that what you can actually do when you do this multiplication is you can just do a blank one and just leave the positions, and then you work out what goes in each of these positions if you want to do it by hand. Okay. So let's actually start doing some by hand and just see how this goes. I'll actually do it in GeoGebra, just check our results in a little while as well. Okay, so here we have A. You can see it's a 2 rows by 3 columns, and B, which is actually, you can see here 1, 2, 3, 3 rows by 2 columns. And you can see here the 3's match up. The resultant is a 2 by 2, okay, as before. Now, let's go through how it's all done. Okay, so let's just do this slowly. Okay, so on the first pour, okay, so let's actually, before we do that, let's just go, what is the first pour? The first pour is this row down in this column. That's the first pour, right? Okay, so and the second pour will be this one down this column. That's the second pour. Okay, so that's this position here, which is 68. Okay, this is row 1, column 2. That's the 68. And the third pour, this one down here, and then the fourth pour would be this one down here. Okay, that'll be the final one, 167. Okay, so on the pour, what happens is it's a bit like sometimes someone said it's like a slinky. You go down the stairs, you go 1 times 7 plus on the next step, 2 times 8 plus 3 times 9. Okay, and that gives you the 50. Okay, so it's 1 times 7 plus 2 times 8 plus 3 times 9. Okay, gives you the 50, and then let's do the next pour. Okay, this one down here. Okay, let's do that pour. Okay, so it's 1 times 10 plus 2 times 11, yeah, and 3. Okay, I'll go through. So it's 3. Okay, 3 times 12. Okay, all right. So the 3 times 12 is obviously here. 3 12s. 36, and if you add all these up, you should actually get 68. Okay. All right. So the next pour. Okay, let's just go on to the next pour. So that was that pour was the second pour, which was actually, if you like, remember, it was row 1 down column 2. So that's in position row 1, column 2. That's the 68. All right. Now, if we start on the next pour, okay, which is the okay, this is the row 2, and I'm going to pour row 2 down column 1 and then column 2, and that's going to give me, if you like, row 2 column 1's answer and row 2 column 2's answer, 167. Okay, so let's actually do this. Okay, so it's 4. Okay, 4 times 7 is 28. 5 times 8, 5 8's are 40, and 6 times 9. Okay, we add all those up, we should get, okay, this is it here, this is the actual calculation we have to do, okay, and that should add up to 122, right? Okay, well, let's now look at the final calculation, which was obviously, it's the second column, by the second row, giving us this one over here, 167. Okay, that's the way. How do we get the 167? Well, if you have a quick look, this is it here. Okay, here it is. 4 times 10 plus 5 times 11. Okay, plus 6 times 12. Okay, and you might remember this is the pour. It goes down the steps. Okay, so it's 4 times 10 plus 5 times 11 plus 6 times 12. Okay, and getting finally 167. Okay. Now here we have A and B, the familiar matrices. But we're going to actually do the multiplication B times A now instead of A times B as we did before in the previous example. So first up, are they compatible? Well, okay, now we have to look at, okay, how do we get compatibility? Remember, it's the columns of the first by the rows of the second. Yes, so we're multiplying B times A, so we always got to watch the order as well. Okay, so that's matching up. Okay, good. And the resultant matrix is a, you can see here, a 3 by 3 resultant matrix, okay, which is this one over here. Okay, now, as I was saying before, what I usually do is just draw a little matrix up with leave blanks, like for the 4768, okay, a 3 by 3 matrix with 9 little spots in it, you can see here, and then try and work out what each of the values are. Now, okay, so we're going to now pour, okay, let's have a look. We're going to pour the first row down the first column. Okay, so it's, you can see here, 7 by 1 plus 10 by 4, okay, which is against 47. That's easy enough. And that's in, if you like, row 1, column 1. Okay, now let's pour the second, we'll do the second pour, which is still row 1 down column 2. Okay, so row 1, column 2, which you can see here is 7 times 2 plus 10 times 5, okay, 10 times 5 is 50, and 14, 64. And that's in, okay, row 1, column 2. Row 1, column 2, here it is, 64, right. Okay, now let's do the third pour. Okay, so this is the third pour, which is the first row down the end column here. Okay, which is, you can see here, 7 times 3 plus 10 times 6, okay. Okay, 60 and 21, 81, okay, it's not too bad. Okay, and you keep on going. Okay, let's pour this one, 8, pour, do that one now, so it's 8 times 1 plus 11 times 4, then do this one. Okay, next pour on this row, so it's 8 times 2 plus 11 times 5. Okay, keep your eye on these ones here. Then let's do the final pour for that row. Okay, so it's 8 times 3 plus 11 times 6. Okay, 90 over here. Okay, let's move on to the final series of pours. Okay, so this is the third row down the first column. So it's 9 times 1 plus 12 times 4. Yeah. Okay, then we do 9 times 2 and 12 times 5, and 9 times 2, 12 times 5, which is this. Okay, it's that row poured down that column. Right, okay, so it's 9 times 2 plus 12 times 5. That's not too bad. And then the final pour for the multiplication, which is in this row too, okay, which is that one down this one. So it's, you can see here, 9 times 3, and 12 times 6, okay, which is 99, okay. And then, okay, that will be in row 3, column 3. Yeah. So it's how you pour it. You pour it from the row down the column, and that tells you where you end up in the actual grid here of the resultant grid over here. So this is the resultant of the multiplication. Okay, this is actually B times A. Okay, let's actually go into GeoGebra now and have a quick look at the result, how we do it on the result. Okay, so a quick look. Here we have, now I've got GeoGebra. I've actually set these matrices up. So let's just go into here and go A times B, okay, equals. Okay, here's A times B, and let's actually do, you can see it's a 2 by 2, B times A, okay. B times A, enter, okay, here we are. Now you can check those two matrices are fine, but you can see here that GeoGebra, this is GeoGebra 5, does matrix multiplication very nicely and neatly. And thank you very much for watching, and bye for now.